Hello and welcome. In this video, we're going to talk about some of the main theorems of calculus: the mean value theorem, the intermediate value theorem, the extreme value theorem, and Rolle's theorem, and how they relate and how they're different, when to use them, and what conditions need to be shown in order to use them. So let's go ahead and jump right in. So we're going to start with the one theorem on this list that we actually have already learned and we went through in chapter 1, and that's the intermediate value theorem. And the intermediate value theorem says that if a function is continuous, that is the key condition that needs to be stated, on some closed interval, and k is a number between f of a and f of b, then there is at least one number c in the interval a to b, such that f of c equals k. So what this means logistically is if I have a closed interval, then every single y value is taken on somewhere between f of a and f of b. So if f is continuous between 2 points, then every single output is covered, right? If I never lift my pencil to go from point A to point B, then I'm passing through k somewhere along the way. It could be once, it could be twice. In this picture, it looks like it's 3 times. The key idea is that the intermediate value theorem guarantees we pass through each value at least once if it's continuous. When you use this to prove that a particular y value has to exist between 2 other y values. Notice this is not going to be used with derivatives, as some of the theorems that we covered today are going to be used with derivatives. Other things to note: when you're writing a justification, you must state that the function is continuous. Even if the problem says that the function is continuous, you need to state it again. That is a part of the requirements. And for purposes of this class, I expect you to state this theorem by name when you're working through it. Obviously, these rules don't apply if it's a multiple choice question like the one we're going to look at. However, what I want you to see is if it's a free response question, regardless of if the directions say the function is continuous, you need to restate it's continuous. That's why we're allowed to use IVT. So we're going to look at just one quick example here, and I picked a multiple choice one since IVT is review. The function is continuous on the interval from a to b and has values that are given in the table below. The equation f of x equals 1/2 must have at least 2 solutions from the interval from 0 to 2 if k equals what value. So I actually encourage you to pause the video and work through this on your own, and then unpause the video to see how you did. So for me, one thing that I like to think about, it just gives me a better visual understanding, is let me just do a quick little tiny sketch of what's going on. We have a function that is continuous from point A to point B. So I never lift my pen when I connect them. In order to have a solution at f of x equals 1/2, that means, I'm going to just graph that here. This is f of x equals 1/2. In order to have at least 2 solutions, this graph is going to have to cross at least 2 times, which means it's going to have to go below 1/2 between 0 and 1, and it's going to have to go below 1/2, or it's going to have to cross 1/2 between 1 and 2. So let's look through each of these answers. If a is 0, then yes, it will go down, or sorry, if k is 0, it will go down, it'll cross here, and it'll cross again. So 0 does work, so I'm going to make a little note of that, but I still want to go back through and check the other answers and see why they don't work. If k is equal to 1/2, then it's possible that this function just does this and it only crosses exactly once, and the question is asking us to make sure it crosses at least twice. So that's why B doesn't work. For C, if it is 1, that doesn't guarantee any times that it goes down at all. Same thing with 2 and with 3. If it's going up at all, that's not guaranteeing it's coming down and crossing the line y equals 1/2. So that's why A is the only answer that works here. So intermediate value theorem, make sure you state that it's continuous, and then you can find a y value, because we're basically saying if it's continuous, we never have to lift our pencil. Let's look at our next theorem. The next theorem we're going to talk about is the mean value theorem, and the mean value theorem does relate to derivatives. What the mean value theorem says is if f is continuous on the closed interval from a to b and differentiable, so two conditions, continuous and differentiable, both of those are going to need to be stated, and differentiable on the open interval because something can't be differentiable on a closed interval, then there exists some c in the open interval such that f prime of c is equal to f of b minus f of a over b minus a. So if we were to just translate this into English out of these math words, this is saying if a function is continuous and differentiable, at some point in time, the average rate of change, aka the slope between the 2 points, the slope of the secant line, at some point will be equal to the actual derivative, the instantaneous rate of change at a particular value for some point c. That makes sense. If I'm driving from here to San Diego and I am averaging 65 miles an hour, at some point in time, I actually needed to be driving 65 miles an hour if I never stopped. So let's go ahead and look at some examples here, and you'll see I have more examples here just because I really want you to get the hang of practicing with the mean value theorem. So when you're answering these free response questions, you need to make sure that you state that the function is continuous and differentiable, even if it's given in the problem. And then for this class, I would like you to state the theorem by name. So when I look at number one is a polynomial, so I know it's continuous and differentiable. So I'm going to state that first. So I'm going to start by stating f is continuous on the interval from -3 to 2 and differentiable on the interval from -3 to 2. Therefore, the mean value theorem applies. Now what I need to do is I need to figure out what the average rate of change on that interval is and what the instantaneous rate of change on that interval is, and then I want to set them equal to each other. So you can set this up as one statement as you go, or you can find them separately, and I'm going to try and do it each way so you can get a different idea of what that looks like. So I'm going to find the average rate of change on this interval is going to be f of 2 minus f of -3 over 2 minus -3. That's going to become 2 plus 3. This is going to be 3 minus 18 over 5, so that's going to be -3. Then I'm going to find the instantaneous rate of change, which is just the derivative, which is 2x minus 2. So what IVT says is that at some point, these two things are going to be equal. And I'm going to just keep working down here. So 2x minus 2 must equal -3 at some point, which is going to give us that x equals -1/2. And just like with the intermediate value theorem, make sure your final answer says C because it says find the value C. Oh, there aren't any directions here. It should say determine if the intermediate value theorem works. If so, find the C. So C is going to equal -1/2. So we're stating the conditions, continuous, differentiable, so MVT applies. We're finding each of these pieces separately and setting them equal to each other to solve for C. I'm going to encourage you to work through number 2 on your own and then go ahead and unpause the video and see how you did. So I'm going to start by stating the conditions, and notice this function is not continuous and differentiable everywhere, but it is on the interval that we're being asked about in this problem. Therefore, the mean value theorem applies. Then I'm going to find the average rate of change on this particular interval, which is going to be f of 2 minus f of 0.2 over 2 minus 0.2, which is going to be 0.5 minus 5 over 1.8, which I'm going to simplify to -5 over 2. The instantaneous rate of change is going to be that f prime of x equals -1 over x squared. So by the mean value theorem, we can set these two things equal to each other. -1 over x squared equals -5 over 2. This is going to get us that x equals plus or minus the square root of 2 over 5. In the interval that we care about, that is just going to be that c equals the square root of 2 over 5. So let's do this last example that I know you can't see, so let me make some room so we can see it. That involves cosine of x. So it says f of x equals cosine of x from pi over 2 to 3 pi over 2. So go ahead and try that one on your own, and I'll make some space, and then we can do it together. So first thing we want to do is state the conditions. Then we want to find the average rate of change and the instantaneous rate of change. After we find the average rate of change and the instantaneous rate of change, we're going to set them equal to each other. So we get that the c value on this particular interval is pi. And I actually intentionally ended with this one in our mean value theorem examples because this ties specifically to Rolle's theorem, which we are going to look at next. So this ties specifically to Rolle's theorem because Rolle's theorem is basically the mean value theorem, except it has one special caveat that we're saying that the derivative has to equal 0, which is exactly what we just did here. So let's talk about Rolle's theorem. So here's what Rolle's theorem says. It says let f be the continuous function on the closed interval from a to b and differentiable on the open interval. So exactly the same conditions as the mean value theorem. If f of a is equal to f of b, so if at some point the function is equal to itself, whether that's on the endpoint or somewhere in the middle, right? We could say that here and here there is the same value. If at some point on that interval f of a is equal to f of b, then there is at least one number c such that the derivative is going to equal 0. So that we're going to have that horizontal tangent line. So what this means, if a function has two places where a and b where the y values are the same, then there will be a horizontal tangent somewhere between a and b. This is used exactly the same way as the mean value theorem. It could actually be used to prove that there's a max or a min value between two x values if you don't have the graph. But really the process is just showing that the derivative must be equal. So this really quick example that we're going to look at, I'm going to note, it says determine if Rolle's theorem applies. So I'm going to note that f is continuous on the interval that we're talking about and differentiable on the open interval. Therefore, Rolle's theorem applies. I'm not so concerned about you using the title Rolle's theorem because you could use the mean value theorem in the same way. So what we're saying is if the derivative is 0 at any point in time, it crosses the function twice, or if the value of the function is crossed twice, then the derivative will be 0 at some point. So what I just want to point out here is that if we check what's happening at the endpoints, if we plug in 1, we get 0. If we plug in 2, we get 0. That means at some point in time, actually, I guess this would be the other part of the conditions here. At some point in time, the derivative is going to be 0. So let's find the derivative, and we can set the derivative equal to 0. That would give me that x is 3 over 2, or the c value that we're looking for potentially would be 3 over 2. So more often than not, you're going to be using this in the same way that you would use the mean value theorem, and you're going to be asked to prove that there's a horizontal tangent. So you could just show that the function is equal to 0 at more than one, or the function is equal to the same value more than once. I haven't seen a ton of questions on the AP test where you're specifically asked to use Rolle's theorem. It's just more that you know the application of that specific case of the mean value theorem. All right, one more theorem before we wrap up, and that's going to be the extreme value theorem. The extreme value theorem says, again, that f is a continuous function on a closed interval. And then what it says is it will attain both an absolute maximum and an absolute minimum on that closed interval. And we've talked about this already. As long as we have a closed interval, at some point the function is the highest and at some point the function is the lowest on that specific closed interval. So every continuous function will have a highest y value and a lowest y value. That's what the extreme value theorem says. The only condition that needs to be stated is that it is continuous on the closed interval. So when you're writing a justification using the extreme value theorem, you need to state that the function is continuous on the closed interval. And that's usually provided in the question, but it doesn't matter. You still need to restate it. And I don't have an example here because, again, most of the time this is something that you're using maybe as a justification in a multiple choice question, or you're being asked to find the extrema. So you can simply state, since f is continuous on this interval, there is an absolute max and an absolute min. Okay, let's tie these together and really look at the differences between them in one last question. Since these theorems are so similar, I felt like the best thing to do would be to really just sort of have a fill in the blank and identify which theorem is being used in which situation. So this says, use the table below with the selected values of the twice differentiable function. So you're being given some information here. Remember, if something is differentiable, that means it is also continuous. Read each explanation and decide whether you would apply IVT, EVT, MVT, or Rolle's theorem. So I actually encourage you to pause the video and work through this on your own, see which ones you can get through, and then unpause the video and see how you did. So hopefully you had time to read through these. Number 1 says, since K is twice differentiable, it's also continuous. Since K of 6 equals 2 and K of 7 equals 0, and since 1 is between 2 and 0, it follows by some theorem that K of C has to be equal to 1 for some C value between 6 and 7. So notice we're not specifically addressing the derivative at all. We're saying we're continuous. This number is between two other numbers. Therefore, we must have an output there. So that's going to give us, that's IVT that we're using here. Number 2 says, since K is differentiable and therefore continuous, this right here looks like average rate of change. So the average rate of change equals -6. It follows by some theorem that K prime of C must equal 6 in the open interval. Well, that is all of the requirements for the mean value theorem. For number 3, there must be a minimum value for K at some R in the interval from 1 to 7 since K is differentiable and therefore continuous. So this is asking us about absolute extrema. That's going to be the extreme value theorem. Number 4, there must be some value A on the open interval for which K prime of A equals 0 since, or because, K of 2 is equal to K of 6. And since K is differentiable. This is Rolle's theorem. And you could also say this is the mean value theorem because it applies in the same way. But specifically, it's Rolle's theorem. And then our last question, since K is differentiable, something guarantees a value for which the derivative equals 4. That's going to be our mean value theorem. And also some B for which that value is there. And actually, let me just show you why a little further. The average rate of change on the interval from 4 to 5 is 3 minus -1 over 5 minus 4, which is going to be 4. So the average rate of change here is 4. So this is saying average rate of change equals derivative. That's the mean value theorem. Similarly, the average rate of change on 5, 6 is going to be equal to -1 over +1 is going to be equal to -1. So that's why this is holding true as well. Then there's a second blank. It says, then since K prime is differentiable, which we know since it says twice differentiable, and therefore also continuous, it follows by a theorem that K prime of C is equal to 0 for some C in the interval from 4 to 6. So that's going to be the intermediate value theorem. So it's important to know the differences between these theorems. It's important to know the conditions that have to be stated and for you to be able to use them in a variety of different ways. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.